Hi, hello, good evening everyone. I hope I am perfectly audible and visible to each and everyone present over here. Anyway, how are you all doing? Everything going well? Okay, fine. Anyway, warm welcome all of you to the E2 channel of Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn for this particular session. Hi Amir, good evening. Okay, anyway, in this particular session, we are going to discuss the practice question in the redox reaction. There is no any new concept, new chapter, only the redox reaction. What we have already covered, we are just revising through the practice questions. Ready? And there is a humble request for all of you. I need your complete attention or complete response from throughout this class because we are focusing on the questions only. Okay, ready? Okay, before that, there is a general reminder about the AITS, that is our All India Test Series. Infinity Learn is providing All India Test Series for JEE Mains 2025 and JEE Advanced 2025, JEE Mains Session 2 and JEE Advanced 2025. And there will be a special discount for all of you. By using this coupon code YouTube 50 off, you will get this complete course around 2,999 only. Okay, don't miss the opportunity. Okay, let us start. Anyway, here is the first question for all of you. Before that, I am just revising that all the topics we have covered in the previous sessions. We have just studied about the oxidation number, concept of oxidation and reduction. Then we studied about the types of redox reactions. Then we studied about the balancing of redox reactions using oxidation number method, half reaction method, and so on. Then finally, we have come across the redox titration, right? Based on these topics, I have prepared some questions for you. This is the first question from this session. The question is, in the reaction, Mg plus N2 gives Mg3N2. What will happen here? Whether the magnesium is reduced, magnesium is oxidized, or nitrogen is oxidized, or both magnesium and nitrogen is oxidized. Okay, what will be the answer? Fine, this is a redox reaction in which magnesium is changing its oxidation number 0 to +2, right? 0 to +2. Here, this nitrogen is in the -3 oxidation state. It is also known as nitride ion. So, as you can see here, the magnesium is changing its oxidation number from 0 to +2, which means that magnesium is oxidized. Therefore, option 2 will be the correct answer. Magnesium is oxidized. Fine. This is the next question for you. In a reaction between zinc and iodine, in which zinc iodide is formed, what is being oxidized? First, you have to write down the chemical equation for this particular reaction. Then find out the particular oxidation numbers of each of the atom present over it. Then find out which one is get oxidized. Okay, what will be the answer? Okay, this will be the reaction. Hi Sandhya, good evening. Okay, this will be the reaction happening here. Zinc is reacting with iodine to form zinc iodide. First, you have to balance the atoms here. Here you can see one zinc is present over both sides of the equation, so it is balanced. Then what about the iodine? How many iodine present in the left hand side? 2, right? So I am putting 2 in front of ZnI in order to balance the whole equation. Then you have to find out the oxidation number of each of the atoms. In the case of zinc, it is 0, right? Because it is in the elemental state. Again, in the case of iodine also, it is 0 because again, iodine is also in their elemental state. That is the iodine molecule. Then what about selenite? It having +1 and -1, right? So as you can see here, zinc is changing its oxidation number from 0 to +1. Otherwise, it is happening oxidation, right? Zinc undergoes oxidation. Then our question is, what is being oxidized? As you can see here, the zinc is in the simple elemental form, right? Which means this is a zinc atom. This is the zinc atom. So we can say that zinc atom is get oxidized here, which means option 3 will be our correct answer. Hi Brahman Mishra, good evening. Option 3 will be the correct answer. Clear? Then the next question is, the reduction does not involve. We have already discussed about the different concepts about the reduction or oxidation, right? Classical concept, oxidation number concept and electronic concept. Based on that idea, you have to give the answer about reduction. Reduction does not involve which of the following options. The first option is this is the removal of an electronegative element. The second one, it is the addition of an electropositive element, or it is the removal of an electropositive element, or the decrease in oxidation number. Okay, what will be the answer? Reduction does not involve. Okay, according to the classical concept, reduction is known as the addition of hydrogen or addition of electropositive element, right? Addition of hydrogen or addition of electropositive element is known as the reduction according to the classical concept. So we can say that this will be the explanation of a reduction, right? Addition of an electropositive element. And also we can say that the removal of oxygen or any electronegative element. Or any electronegative element. That will also the definition of reduction. So we can say that the removal of an electronegative element is also corresponds to the reduction part. Then decrease in oxidation number also corresponds to the reduction part. What will be the one which does not involve the reduction? That is the removal of an electropositive element, which means option 3 will be the correct answer here. Clear? Clear? Okay, fine. Here is the next question. The oxidation state or states of chlorine in CaOCl2, otherwise bleaching powder, is or are. 2 chlorine atoms are present here in the case of bleaching powder. What are their oxidation states? This is a special case of structure, right? We have to find out the oxidation number using their structure only. What will be the answer? Okay, this will be the structure of bleaching powder or CaOCl2. As you can see here, while discussing about the oxygen state of special structure, I have already mentioned that whenever you have the two atoms having the difference in electronegativity, you must add the oxidation numbers according to their electronegativity. As you can see here, if I am taking calcium chloride bond here, if I am taking this calcium chlorine bond, which one is more electronegative? Calcium or chlorine? Chlorine, right? Because chlorine has the highest attraction power to attract the shared pair of electrons. So it will attract these pair of electrons acquiring a -1 charge. Then calcium will acquire a +1 charge. Clear? Because of their electronegativity difference. Then what about calcium and oxygen? Here also oxygen is electronegativity, right? Oxygen is more electronegative, so it will acquire -1 charge. Then calcium will acquire +1 again. Then what about here oxygen and chlorine? According to oxygen and chlorine, oxygen is more electronegative than chlorine, so it acquires -1 charge here. Then chlorine will experience +1 charge, which means that in the case of calcium CaOCl2 or bleaching powder, the first chlorine will acquire -1 charge, the second chlorine will acquire +1 charge. So the option 3 +1 and -1 will be the correct answer. Clear? Hi Shreyas, good evening. Okay, now let me move to the next question. Here is the question. In the case of S4O6 the oxidation numbers of 4 sulfur atoms are. First, you must have an idea about the structure of S4O6 Then find out the oxidation numbers of each of the sulfur atoms. 4 sulfur atoms are present here. Find out the oxidation numbers of each of the sulfur atoms here. What will be the answer? Okay, Shreyas, you have just calculated the oxidation numbers, right? From the formula, right? Then you got 2.5. But this will be the wrong answer. In the case of this particular case, you have to consider structure only, right? This is a special case, you have to consider structure. So as you can see here, this will be the structure of S4O6 ions, right? 3 oxygen, 3 plus 3 or 6 oxygen plus 4 sulfur atoms. And as I already mentioned that there will be a consideration of electronegativity difference, right? Here, in the case of oxygen and sulfur, which one is more electronegative? Oxygen and sulfur. Oxygen is more electronegative, right? So it will acquire -1 charge here because of the presence of the electronegativity. Then due to this -1 electron charge, this sulfur will experience +1 charge due to this oxygen. Similarly, if we are having 2 bonds, it will acquire -2 charge over here. Here it will acquire +2 charge. Similarly, for this oxygen also -2 and +2. Clear how we are calculating the oxidation numbers? Clear? So for this particular sulfur atom, the charge will be 2 plus 2 plus 1, that is equal to 5. For this it is equal to 5, right? Plus 5. Then what about here? These two sulfur atoms are same, right? So there is no any electronegativity difference. It will experience the oxidation numbers of 0 each, right? It is in the same bond, therefore sulfur having 0, 0 oxidation state, right? Then what about here? Same happening here also, right? Here, due to this presence of this oxygen, double bond oxygen, it will acquire minus 2, it will acquire plus 2. Similarly, here it is minus 1, here plus 1. Here it is again minus 2, here it is plus 1. In total, the total charge of the sulfur will be again plus 5. So, our correct answer will be plus 5, 0, 0 and plus 5, which means option 3 will be the correct answer. Clear? Yes, Dishang, you are correct. Aryang, you are also correct. Is it clear? Yes, here is the next question for you. Again, to calculate the oxidation numbers of CrO5 and K2Cr2O7 respectively are. What will be the answer? CrO5 and K2Cr2O7. Yes, option 3, right? Any other options? Yes, option 3 will be the correct answer. How we can approach this question? CrO5, right? This is a special structure in which have a butterfly structure, right? I have already mentioned in your concept classes. This is a structure of CrO5. This is a butterfly structure in which due to electronegativity difference, this will acquire minus 1 charge, right? This is minus 1. Due to this electronegativity difference, this chromium experience plus 1 here. Similarly, here again plus minus 1 plus 1. Here it is 2 bonds, right? So it is minus 2 plus 2. Here it is minus 1 plus 1, minus 1 plus 1, right? In total, the charge experience on the chromium atom is 2 plus 1 plus 1 plus 1, that is equal to plus 6, right? Equal to plus 6. Okay, then what about the Cr2O7 2 minus? Here it is K2Cr2O7 2 minus, right? That is potassium dichromate. There is no any special consideration. We have to just calculate by the numbers. For 2 potassium, it is 2 plus 2x minus 14 is equal to 0 because the algebraic sum is equal to 0. Then 2 minus 14 minus 12, 2x minus 12 is equal to 0 or x is equal to plus 6. Which means option 3, 6 and 6 will be the correct answer. Clear? Okay, then now here is the next question for you. Yes. An equation is given here, that is NO2 minus plus H2 gives NO3 minus plus 2H plus plus N electron. What is the value of N here? What is the value of N here? This question is based on the balanced redox reaction. Concept of balancing the redox reaction. What will be the answer? No answers. Okay, according to the balanced redox reaction, we have an idea that the total charge should be equal, right? Charge in the reactant side should be equal to that of the charge in the product side also. So, if you are calculating the charge here, what will be the total charge here in the case of reactant side? Okay, Aryang, fine. Just take the answers. I will explain. Okay, what will be the total charge in the reactant side? Here it is -1 plus 0, right? What will be the total charge? -1, right? This is the -1 charge, total charge. Then what about here? Here it is -1 plus 2 plus charge, right? 2H plus 2. Then for one electron it is having -1 charge. For n electrons it will be having -n charge. For the simplicity I am taking -n. Then just do the final calculations here. What will be the answer? -1 is equal to 2 minus 1 minus n, or n is equal to 1 plus 1, right? 1 plus 1 is equal to 2. Which means option C will be the correct answer. Clear? How we are calculating the number? The concept behind this question is that in the case of a balanced redox reaction, the total charge in the reactant side should be equal to the total charge on the product side. So we are just equating the charges, then find out the value of n here. Clear? Okay, fine. Now here is the next question. Again based on the balancing redox reaction. Here one equation is given. For the redox reaction, MnO4 minus plus C2O4 minus plus H plus gives Mn2 plus CO2 plus water. What are the correct coefficients of the reactants MnO4 minus, C2O4 minus and H plus for this balanced reaction? Okay, I hope everyone can understand the balancing of the redox reaction. You can use either oxidation number method or half electron method to balance this particular reaction and find out the coefficients. What will be the answer? Just let me know. You can use any of the method, oxidation number method or half electron method. No answers? In order to solve this question, first you have to identify the oxidation numbers each of the atoms. Here it is MnO4 minus, right? So manganese having +7 oxidation state. Then what about here? In the case of carbon, here it is +2, here it is +4, right? What about here? So that we have just calculated the oxidation numbers of each of the atom. As you can see here, in the case of particular reaction, manganese is undergoing reduction, right? It is changing its oxidation number from +7 to +2. So MnO4 minus plus C2O4 minus In order to balance this equation, we are just removing the H plus and H2 from the question. So we are adding Mn plus 2 plus CO2, right? Then if we are solving it with the oxidation number method, first you have to find out the change in oxidation number, right? Change in oxidation number in both oxidation and reduction. What will be the change in oxidation number in the case of reduction? That is from MnO4 minus to Mn plus 2. What is the change here? It is changing from plus 7 to plus 2, right? Plus 7 to plus 2, which means change is equal to 5. Then what about here? It is changing from plus 3 to plus 4, right? For change is equal to 1. For change is equal to 1, right? Change is equal to 1. Then you can see that here 2 carbon is representing, right? 2 carbon. For 2 carbon, the change will be 1 into 2, right? 1 into 2. Then in order to before cross multiplying these changes, you have to just balance the atoms. Here manganese only 1, both are balanced. What about the carbon? Here it is 2 carbon, but here it is only 1 carbon, right? So I am putting 2 here. Then after that you have to cross multiplying these changes, right? Cross multiplying these changes. What you will do now? You just multiply these 5 with the C2O2 minus. Then how it will become 5 into 2 CO2, right? I will write here. Do you have any doubt in this particular step? Aryang, my Hindi is not that much good, that's why I am not speaking in Hindi. I can understand Hindi also. No issues. Is there any doubt in this particular step? How we are changing the oxidation number and all? Then we have already balanced here. Now the remaining oxygen hydrogen atom have to be balanced. Here it is 2 into 4, 8 plus 5 into 4, 20, 28, right? 28 oxygen is present in the left hand side. What about here? It is only 5 into 10, right? What we are adding? We are just adding the water molecule here. While adding the water molecule, here it is 2 into 4, 8 plus 5 into 4, 20, 28 oxygen is present. So we are adding 10 plus 18 water molecule, right? Did you see any mistake here? Here the number of carbon dioxide will be 10 only because we have to multiply it with 2 into 5. This will become 10 CO2. Then what about here? Here it is 2 into 4, 8 plus 20, 28 oxygen atom. Here it is 20 oxygen atom. So I am adding only 8 water molecules. Only 8 water molecules. So that we will get 8 into 2, 16 H plus. So in order to balance the hydrogen atom also, I am just adding here 16 H plus. So this will be the complete balanced redox reaction. As you can see here, the charge is also balanced here. So according to our question, we have to find out the coefficients for the MnO4 minus, right? It is 2. Then what about C2O4 minus? It is 5. Then for H plus it is 16, right? Which means option A 2, 5, 16 will be the correct answer. Clear? Clear? In order to solve this question, you must have an idea about the balancing of redox reaction. In any of the method, whether it is oxidation number method or half electron method, no worries. You just calculate the oxidation numbers and find out the balancing redox reaction using any of the method. Clear? Okay. Here is the next question. What is the sum of oxidation numbers of nitrogen in ammonium nitrite? Ammonium nitrite. The chemical formula of this particular substance is also given here, NH4NO2. Find out the oxidation numbers of each of the nitrogen atom present here. Then find out the sum of the oxidation numbers. What will be the answer? Zero, right? Any other options? Hi Samir, good evening. Yes, option 2, 0 will be the correct answer. How we can calculate this? This is a structure, this is a compound, right? NH4NO2. So separately you have to find out the oxidation numbers of here. And there is a point you have to note that this NH4NO2 will dissociate or split it to form NH4 plus and NH4 plus and NO2 minus, right? So first you have to find out the oxidation numbers of this particular nitrogen. It will be x plus 4 is equal to plus 1 or x is equal to 1 minus 4, right? That is equal to minus 3, right? Then what about the second one? This is NO2 minus, right? X minus 4. Minus 4 stands for the oxidation numbers of two oxygen atom. That is equal to minus 1, or x is equal to 1 minus 1 plus 4, that is equal to 3, right? The first nitrogen atom possesses minus 3 charge and the second nitrogen atom possesses plus 3 charge. In total, minus 3 plus 3 is equal to 0. Clear? Okay, fine. Now here is the next question. Again, to find out the value of N, and the question is that Cr2O7 2 minus plus 14H plus plus NFe2 plus gives 2Cr3 plus plus NFe3 plus plus 7H2. And it's already given that the equation is balanced. You have to find out the number of N here. What will be the coefficient of Fe2 plus and Fe3 plus here? That is the question. Okay, Aryan, no need to worry. You have the session 2 also, right? In the April, there is a session 2 exam. Prepare for that exam also. Okay, one more thing you have to note that if you are preparing for any exams, so in which subject you are facing difficulty, take more time for reading or learning that subject, right? Whether it is chemistry, physics or maths. Okay, what is the answer here? According to the balanced redox reaction, the total charge should be equal, right, from the both of the side. As you can see here, it is -2 plus 14 plus 2n. Plus 2 will be the charge of one iron atom. For n atom, it will be 2n. Then what about here? 2 into 3, 6, right? Plus 6 plus 3n. This is a neutral, therefore it will be 0. While calculating here, you will get 12 plus 2n is equal to 6 plus 3n. Or 12 minus 6 is equal to n, right? Is equal to n is equal to 6, which means option 4 will be the correct answer. Clear? Okay, Aryan, take more time to solve the math questions, right? If you are facing difficulty in the maths, practice questions in the maths. Practice the previous year questions. Is it clear? Here is the next question. Again, to find out the stoichiometric coefficient. The reaction is MnO4 plus Fe2 plus H plus gives Mn2 plus Fe3 plus H2O. This is MnO4 minus, right? What will be the stoichiometric coefficient associated with H plus in the particular equation? What is the answer here? Eight, right? First you have to find out the balanced chemical equation for this reaction. Here it is plus 7, right? Plus 7 to plus 2, change is 5. Then what about here? Fe2 plus Fe3, change is 1, right? Just cross multiplying the charges, cross multiplying the changes, so it will form, here it is 1, right? 1 MnO4 minus plus 5 Fe2 plus gives 5 Fe3 plus H2O. First you have to balance the oxygen atoms. Whenever you are getting the question, first delete these H plus and H2O from this particular reaction, then find out the balancing of the reaction. You will get here it is 4 oxygen atom, right? So I am adding 4 water molecule here. Then total how many H plus ion will be present here in order to balance the hydrogen atom? Here it is 4 into 2, so I will take it as 8 H plus, right? 8 H plus. Here the stoichiometric coefficient of H plus will be 8. Option 3. Clear? Here this particular equation I am solving or balancing with the oxidation number method. You can use the ion electron method or half reaction method also. You will get the same answer. Okay, here is the next question. There is the equation is given. You have to find out the how many number of OH minus ions are appearing in the given balanced equation. Given balanced equation. Okay, fine. In the case of ionic equilibrium, you will just go through the NCERT textbook and practice the previous year questions. Mainly, you can practice the JEE Main January questions, right? It will be helpful. And also, you can enroll our All India test series for the JEE Main session 2. Okay, what is the answer here? Option 3, right? 4. How we can calculate this? It is already given that this is a balanced equation, right? So here CrOH thrice plus H2O2 gives H2O. First balance the hydrogen atom here. Here it is 2, right? 2 hydrogen. 2 plus 3, 5 hydrogen, right? So we have to add in here also. This is the peroxide linkage, right? Therefore, oxygen will experience -1 charge here. Here it is -2, so it is changing from -1 to -2. For one oxygen atom, the change is 1. Here it is 2 oxygen atoms are present, right? So I am taking the change is equal to 2 here. Change is equal to 2 here. Then you have to just balance the oxygen atom here. Then I am just cross multiplying the changes here. What will happen here? I am multiplying it with 2. 2 CrOH3 plus 2 CrO4. 2 minus, then again 3H2O2 plus 3H2O. Then how many oxygen atoms are present here? 2 into 3, 6, right? 6 plus 3 into 2, 6 again. 6 plus 6, 12 oxygen here. What about here? 2 into 4, 8 plus 3 into 1, 8 plus 3, 11. Only one water molecule is deficient here, right? One oxygen atom is deficient. So I am again taking H2O here. Then what about hydrogen atom here? Here it is 3 into 2, 6 hydrogen, right? 6 hydrogen plus 8 hydrogen. 6 hydrogen plus 2 is equal to 8 hydrogen. What about here? 2 into 3, 6 hydrogen plus 3 into 2, 6. Again 12 hydrogen, right? Here the deficiency is H plus ion, right? How many number of H plus ions are deficient here? 4 H plus, right? Then in this particular equation, it is given that the equation is in the basic medium. So if you are taking the basic medium, the last point you have to note that we have to add same number of OH minus ion to the both of the sides. Here only 4H plus is present, so I am adding 4 OH minus here. Again here also I am adding 4 OH minus. Then these 4H plus and 4 OH minus will combine together to form 4 water molecule. 4 plus 1, 5 water molecule. In total it will become 4 plus 1, 5 water molecule. Water molecule, and here it is 4 OH minus. The question is what will be the number of OH minus ions present in the particular reaction, which means option 4 is the correct answer. Clear? Again here is the next question based on the balancing of the redox reaction. The reaction is MnO4 minus plus SO3 2 minus plus H plus gives Mn2 plus plus SO4 2 minus. What will be the number of H plus ions present here? Option 2 or answer 2? Samir? Okay, I hope it is option 2. Yes, option 2 is 6 is the correct answer here. What we have to do? We have to just first calculate the oxidation numbers of each of the atom, then find out the change in oxidation number. Here it is +7 and again it is +2. Change is 5, right? Here it is 5. So I am multiplying here with the cross multiplying with the change 5 here. Then what about here? Here it is -2 + 6, that is equal to 4, right? +4. Then what about here? -2 + 8, that is equal to +6. The change is 2, right? Change is 2. Now you have to balance the oxygen atoms here. Here it is 2 into 4, 8 plus 5 into 3, 15. 15 plus 8, 23 oxygen is present here, right? 23 oxygen is present here. What about here? It is only 5 into 4, 20. So we are adding 3 water molecules, right? 3 water molecules. Then what about the hydrogen atoms? 3 into 2, 6 hydrogen atoms are present. So I am adding 6 H plus ions in the left hand side. 6 H plus ions in the left hand side. Therefore, the number of H plus ions involved in this particular reaction is 6. Option 2 is the correct answer. Clear? Oh, okay, Samir, fine. Did you get the answer now? Or any confusions? Okay, fine. Now here is the next question. Okay. The value of N in the reaction, that is MnO4 minus plus 8H plus N electron gives Mn2 plus 4H2. What will be the value of N? Option 1, right? Yes, option 1 is equal to 5 is the correct answer here. Which means you have to just calculate the charges here. Here it is -1 plus 8 plus N electron. That is equal to +2, right? I am taking minus N charge here. Here it is 8 minus 7. 8 minus 1 is equal to 7. Minus N is equal to 2. Or N is equal to 7 minus 2, that is equal to 5. Clear? Otherwise, you can do the complete balancing of the reaction using half electron method. This will be the oxidation half of the reaction. You have to just balance the oxidation half of this reaction. You will get the answer of N is equal to 5. Clear? Okay, now here is the next question. Okay. From this question, we will start with the concept of redox titration. The question is the number of moles of acidified KMnO4. Acidified KMnO4 required that can oxidize 0.5 mole of more salt. 0.5 mole of more salt. Okay, what is the answer? Point 1, right? Yes, option 3. Point 1 is the correct answer here. This is the particular reaction for this particular reaction. This MnO4 comes from the potassium permanganate having the charge of +7. In the case of acidic medium, it will changes its oxidation number from +7 to +2. Okay, +7 to +2. Then what about here? Here the Fe2 plus comes from the more salt, that is the FeSO4, ferrous sulfate and ammonium sulfate. So it will change from +2 to +3. Then you have to find out the N factor for this particular reaction. What do you mean by the N factor? What will be the N factor here? The number of electrons gained or lost, right? Here 5 electrons are losing, so N factor is equal to 5. Then what about the Fe2 plus ion? N factor is equal to 1, right? Changing from +2 to +3, therefore N factor is equal to 1. So according to the redox titration, the number of gram equivalents of oxidizing agent is equal to the number of gram equivalents of reducing agent. So we are just multiplying with the N factor into mole. If I am taking number of moles of KMnO4, we don't know, so I am taking N of KMnO4 into, what is the N factor here in KMnO4? It is 5, right? That is equal to the N factor of Fe2 plus 1 into their mole. It is given 0.5, right? 0.5. By calculating here you will get the answer of number of moles of KMnO4 is equal to 0.1. Clear? Okay, here is the next question. The number of electrons involved in the reduction of Cr2O7 2- ion in the acidic solution to Cr3 plus. Okay, in the case of acidic medium, the dichromate ion changes to Cr3 plus ion, right? Here only 2 chromium is present, so I am multiplying it with the 2, which means that it is changing its oxidation number from +6 to +3, which means that 3 electrons are losing for 1 chromium atom. If we are taking 2 chromium atom, 2 into 3, 6 electrons are losing, right? 6 electrons are losing, which means option 4 will be the correct answer. Clear? Okay, Samir, if you are considering only 1 chromium atom, it is +3. Here you have to consider 2 chromium atom, right? Because it is Cr2O7, it is only 1 Cr3 plus. Right? Clear? Okay, here is the next question. The number of electrons lost or gained during the change of FeH2O gives Fe3O4 plus H2O. What is the answer? 8, right? While calculating, you will get the oxidation number of around 8 by 3. Here 3 iron atoms are present, so we are taking 3 into 8 by 3, that is equal to 8. Clear? The number of electrons lost or gained during this reaction will be 3 into 8 by 3, that is equal to 8. Clear? Okay, we have more questions to solve. Okay, here is the next question. What is the number of moles of ferrous oxalate oxidized by 1 mole of KMnO4 in acidic medium? This is the ferrous oxalate. This will react with KMnO4 in acidic medium. First, you have to calculate the oxidation numbers of each of the atom. You can see here in the case of oxalate ion, both iron and carbon get changed in their oxidation numbers, right? So here it is +2 to +3, and for carbon it is +3 to +4. So we are taking the n factor is equal to the sum of these two atoms, right? Sum of these two atoms. Then for one carbon atom, it is changing from +3 to +4, that is 1 electron, right? If you are taking 2 carbon atoms, the change will be 1 into 2, that is equal to 2. So the n factor for this particular reaction for the FeC2O4 will be sum of these two atoms, that is 1 plus 2, that is equal to 3. 1 plus 2, that is equal to 3. Then what about the KMnO4? It is changing from +7 to +2, right? Therefore n factor is equal to, for this case, n factor is equal to 5. Then according to the redox titration, you will just multiply the n factor into mole. N factor into mole. Then you will get here, if you are taking 1 mole of KMnO4, it is equal to 1 into 5. Then you have to find out the number of moles of ferrous oxalate, right? So I am taking x here into 3, right? Then x will equal to 5 by 3. Clear? Option 4 will be the correct answer. Clear? Okay, here is the next question. Which of the following reactions are disproportionation reactions? Disproportionation reactions. 4 options are given here. First, find out the oxidation numbers and undergo which one is and identify which one is undergoing disproportionation reaction. We have already studied about the types of redox reactions, right? In the case of disproportionation reaction, the same element from the compound undergo oxidation as well as reduction simultaneously. So you have to just calculate the oxidation numbers and find out which one undergoing disproportionation reaction. What will be the answer? Okay, while calculating the oxidation number, you will get that in the case of first reaction and second reaction, it will undergo oxidation and reduction simultaneously. So these two are the examples of disproportionation reaction here, which means option 1 will be the correct answer. Clear? Okay, here is the last question from this practice session. It is given that 0.8 molar FeSO4 solution requires 160 milliliter of 0.2 molar Al2Cr2O7 tries in an acidic medium. Calculate the volume of FeSO4 consumed. Calculate the volume of FeSO4 consumed. Option 2, right? Option 2 is the correct answer here. That is 240 milliliter, right? If I am taking 0.8 molar, 0.8 into, then what about the n factor here? If I am taking FeSO4, it will change from Fe plus 2 to Fe plus 3. So n factor will be 1. Then what about the volume? Volume we have to find out. So volume of FeSO4 is equal to molarity of this reaction aluminum dichromate is 0.2 into n factor. In the case of Cr2O7 2 minus, it will changes from Cr3 plus, which means 6 is the n factor, right? 6 is the n factor into volume is given as 160 milliliter. What will be the final answer here? $240 milliliter, right? 6 into 40, 240 milliliter. Clear? Okay, tell me how you are calculating this. How are you getting 720 milliliter? This is ferrous sulfate, right? Which will be the plus 2 change. It will changes to plus 3 only. If it is ferric sulfate, there will be the changes from 720 milliliter. Clear? Okay, fine. Okay. This was the last question, and this is all from my side for today. So far, we have successfully completed our redox reaction chapter. We have all the topics we have already covered and also practiced some questions also. Then there is a small change in your time schedule. Tomorrow I will be coming for live from 5 to 6 only. Tomorrow onwards the time will be from 5 to 6. Be ready for that. Then again the gentle reminder for the AITS All India Test Series. I have already mentioned that there is a special discount of 2,999 by using the YouTube 50 off code. Don't miss it. Is there any doubt? Okay, I hope you guys are enjoying the session for today. Don't forget to subscribe our channel, hit the like button also, and share this particular session to your friends also, friends and family also. Anyway, see you tomorrow at the time of 5 to 6. Will be the new chapter with the new chapter, that is chemical molding and molecular structure. Be ready for that. Anyway, thank you so much. Good night all of you.